everyone. Today we're going to take a brief look at what chemical reactions are and how we represent them. A chemical property is one that requires a chemical reaction in order to witness the property. So this means that the chemicals involved will fundamentally be changed as a result. So what are some examples of a chemical reaction? Where do you see something that drastically changes when you observe that property? Some chemical properties might include the ability to rust, such as iron having the ability to rust when it's exposed to oxygen. Being flammable. When something is flammable, it burns, and then there is something very different on the other side. Also, whether something is acidic or basic might also be considered a chemical property. Most chemical changes are generally considered irreversible. While technically in theory it is possible to reverse any change, these are generally considered too difficult for the most part to perform in most settings. Conversely, a physical property would be one that does not require a chemical change to occur in order to witness it. A lot of chemical properties will simply be those that are observed through the five senses, although some of them would require a physical change, one where the type of matter involved doesn't change its form in order to observe it. So what might be some physical properties? Some examples of physical properties could include things such as color or smell. It might also include things like density, where I can do the measurements for it and very easily find it without changing the matter. It might also include things like malleability, where I do a physical change, hammering it into a new shape, but I do not change what the chemical composition of the thing is itself. Most physical changes are generally considered reversible. If the change occurs, you could generally put it back to its original shape. Not all will be reversible though. For example, if I cut up a piece of paper, I could tape it back together, but it won't quite ever be the same. So, how do we know if a chemical change has occurred? Generally speaking, there are four primary pieces of evidence that we look to in order to indicate that a chemical change has occurred. These were shown as demonstrations in class. For example, with the whoosh bottle demonstration, consider what happens in that demonstration and how is it evidence that a change has occurred. What we see is there is fire and we hear a sound, and there is heat, especially if you touch the bottle afterwards, it is still warm to the touch. So the presence of heat or light can be evidence that a reaction has occurred. Another one we looked at was the combination of potassium thiocyanate, a colorless solution, and iron 3 nitrate, a pale orange solution. When the two solutions are combined, a blood red solution results. So what do we see that is evidence in this case? We see a color change. A change in color can indicate that a new compound is present, and therefore color change is evidence that a chemical reaction has occurred. Another demonstration we did was the combination of silver nitrate, a clear solution, and a chloride solution, such as calcium chloride or sodium chloride or potassium chloride. When these two clear solutions are combined, a white solid precipitate, known as silver chloride, falls out of solution. That formation of a solid precipitate that was not present before is another example of something that can be used as evidence to prove a chemical change has occurred. Our fourth piece is what occurred when we dropped the Alka-Seltzer into the water. We saw the formation of bubbles, suggesting that a new gas has been created. Therefore, the presence of a new gas, which was usually generally seen in the form of bubbles, is another evidence that a chemical change has occurred. So a quick overview of our four primary indicators that a chemical change has taken place. One or more of these changes can be present in order to help indicate that a chemical change has occurred. There can be heat or light. There can be a color change, a formation of a solid precipitate, or a formation of gas bubbles. Again, there are technically other indicators we could use, but these are the four most common ones, and there could be multiple going on at once. Let's do a little bit of how we express chemical reactions. A review of chemical formulas, which we haven't seen for a little while. Chemical formulas are a representation of what is present in a compound, specifically by representing how many of each kind of atom is found in it. There are many different compounds that we have looked at. For example, H2O, CH4, NH3, NaCl, and CaSO4. Within a formula, you might find a subscript, the smaller number that is below. The purpose of the subscript is to indicate how many of the particular atom is present. For example, in H2O, the 2 is right after the H, telling you that there are 2 hydrogens present. If there is no subscript expressed, it is assumed the subscript is technically a 1. So for example, in H2O, The O doesn't have a subscript following it. There is an unspoken 1 that follows it technically. There is 1 oxygen in H2O. Chemical formulas pop up in chemical equations, which are used to represent chemical reactions, basically by writing out the chemical formulas for the things that are involved, and both on the product side and the reactant side. For example, the chemical equation for photosynthesis that you likely saw in biology is 6 carbon dioxide gas plus 6 water vapor yields glucose and 6 oxygen gas. Let's take a look at what is found in a chemical equation. In a chemical equation, you may see that there are larger numbers out in front, in addition to the smaller subscripts that are found within the formulas themselves. The large numbers found in front are known as coefficients, the same as they are in math. They communicate how many of the given atom or molecule that follows them is used in the reaction. So for example, look at where CO2 is placed in the reaction and look at the coefficient in front of it. CO2 has a coefficient of 6, which means every time I run this reaction, I must consume 6 molecules of carbon dioxide. We should also talk about what we call the different chemicals involved. The chemicals that are present at the beginning of the reaction are known as reactants. In a chemical equation, we will find them on the left-hand side of the arrow. So in this case, the carbon dioxide and the water vapor would be the reactants. The chemicals that are present at the end of the reaction are called the products. They are on the right-hand side of the arrow. So for example, in photosynthesis, the products would be glucose and oxygen gas. The arrow is specifically known as a yield sign. So specifically, if we want to read this, the more proper way to read this reaction would be that 6 carbon dioxides and 6 water vapor yields glucose and 6 oxygens. Now you have a basic information about how to know when a chemical reaction occurs and how we represent them in chemical equations. We will explore more about chemical reactions this unit.